We're trying to write an equation that has the roots x equals 3, positive 1, and negative 4. So the first thing that we want to do, and this is the long way, some of you may be able to skip this step, but I'm going to write it out anyway. I'm going to write it out separately. X equals 3, x equals 1, x equals negative 4. So what I want to do now is move these numbers over to the left side of this equation so that they're with x. And that way I will have three things set equal to 0, and that's what I'm actually going to multiply. So I'm going to subtract 3 from both sides, and that gives me x minus 3 equals 0. Here I'm going to subtract 1 from both sides, and that gives me x minus 1 equals 0. And then on this last one, I would be adding 4 to both sides, giving me x plus 4 equals 0. So the shortcut is, if you once you do these things enough, you'll notice that you take these three numbers and then you just change their sign. So this is positive 3, and then down here it becomes negative 3 in this first equation. Positive 1 becomes negative 1, and then negative 1 becomes positive 4. Now what I'm going to do is take these three things and I'm going to put them in parentheses, and I'm going to put them all next to each other. So I'm going to have x minus 3 times x minus 1 times x plus 4, and now those things will all equal 0. Now I'm going to have to do some multiplying here. So I'm going to pick any two. I tend to like to choose the second two to multiply out, and then I kind of drop this this last one down, x minus 3, and then that's going to get multiplied by the trinomial that I get after I multiply those second two sets of parentheses. So I'm going to do that. I'm going to do a little bit of scratch work over here. X minus 1 times x plus 4. So this one, depending on how you learned how to multiply binomials, it's what you're really doing is FOIL. So if I multiply the first terms, that's x times x, or x squared. The outer terms is x times 4, which is 4x. The inner terms would be negative 1x, and then the last terms would be negative 1 times 4, which is negative 4. Now these two terms can get combined. If you do 3x and negative 1x, that's a total of 3x. So what goes in these pink parentheses here is x squared plus 3x because it's positive, and then minus 4. Now we have to multiply again, and this time we can't really use FOIL because we're multiplying a binomial times a trinomial. So what I like to do is just be very systematic. So I take my x term and I'm going to multiply it. I'm going to distribute it to the three terms that are blue. So I'm going to do x times x squared, x times 3x, and x times negative 4. So x times x squared is x cubed. X times 3x would be positive 3x squared. And then x times negative 4 would be negative 4x. Now I'm going to do the same exact thing with the negative 3. So now I'm going to take this negative 3 and I'm going to multiply it by x squared, by 3x, and by negative 4. And I like to line things up to kind of save myself a little time later. So negative 3 times x squared is negative 3x squared, and you'll notice I lined it up under the other x squared term. Negative 3 times 3x is negative 9x. And then negative 3 times negative 4 is plus 12. So now I'm going to add these things together, and I've already lined up my like terms, so I don't have to really worry about searching for them. So x cubed is the only cubed term. 3x squared minus 3x squared cancels itself out. Negative 4x minus 9x is negative 13x, and then this plus 12 just kind of drops down. And then I dropped this equals 0, just tagged along towards the end. So this is my equation. I'm done with my equation part. Now I have a graph over here where I have to draw a sketch. So this does not have to be anything really elaborate. There are two features of the graph that we want to make sure you have on there. The first feature of the graph is where the zeros are. So I'm going to draw some tick marks. So my zeros are at positive 3, positive 1, and negative 4. So those are really important to have on there. The other feature we want you to have on the graph is your y-intercept. And the y-intercept is actually really easy to find. The y-intercept you find by looking at your equation, and then whatever your constant value is. So in this problem, our constant value is 12. So I'm not going to draw 12 tick marks, but I'm just going to put a little bar up here and say that that's 12. So this is where our graph should cross the y-axis. At this point, what we're going to do is type what I have here in like a teal color. I'm going to type that into my calculator, and we're going to just use it to kind of draw a sketch of this graph. And what else is really nice about this is when I go to my graph, if my graph on the calculator doesn't match those two features that I put on my sketch, I'm going to know that there's something wrong. Either my equation is wrong or I typed something into the calculator wrong. So I'm putting in x cubed minus 13x plus 12, and then I'm going to go to the graph. And you can't see it because it's up a little bit too high, but the y-intercept, it would be up here at 12. And I can see that it does cross through at -4, it crosses through at +1, and it crosses through at 3. So everything kind of checks out. Now all I really need to focus on is what this graph looks like. So I'm going to go back to my paper here. And like I said, it doesn't have to be really elaborate. It just has to be, a basic sketch of what it should look like. So it started down here. It came up through the y-intercept, down through the 0 at 1, and then back up through the 0 at 3. So that's as complicated as your sketch needs to be.